Hi guys, in today's video we're going to look at the rate determining step, how we can predict the reaction mechanism, orders and the rate determining step, orders and mechanism, and finally an exam style question.
What exactly the rate determining step is? Well, reactions can have many steps. They have what we call a reaction mechanism, where a series of steps fit together to make up the overall reaction. Now, the slowest step in this reaction mechanism is our rate determining step. So let's just visualise this. Say we were making this lovely cake over here. Well, there are many steps in the preparation and making of our cake. We'd have to sift our flour, weigh out our butter, crack our eggs and mix the mixture together. We then have to put our cake mixture into a cake pan and put it into our oven for a certain length of time. Now, if we wanted to increase the rate, we could sift faster and mix faster. But if our oven can only hold so many cakes and they all have to cook for a certain amount of time at a certain temperature, we can't increase the rate of that step any further. That's our slowest step and therefore our rate determining step. So when we measure the rate of any reaction that has a multi-step reaction mechanism, we're effectively measuring the rate of this rate determining step. We can't go any faster than our slowest step. So let's look at how we can use rate equation to predict the reaction mechanism. While some reactants have no influence on rate, we know there are zero order reactants, and only molecules in our rate equation are involved in the rate determining step. So if we look at this equation here, this is the overall equation for the hydrolysis of bromomethane. Now below we have the rate equation, and now you can see that the hydroxide ion is not involved in the rate equation, only bromomethane, indicating that only bromomethane is involved in the rate determining step. So in our first step, our rate determining step, we have only bromomethane, suggesting that the CBr bond must be broken before the hydroxide ion can take its place. Now you'll see we're forming a CH3 plus ion. This is what we call an intermediate. It's a species that's formed in one step of our multi-step reaction and it's used up in a subsequent step, so it's not seen as either a reactant or a product, as you won't see it here in our products. You can see it's made in step 1 and it's used up in step 2, so we don't see it in our overall products.
Hey guys, to continue watching this video and unlock hundreds of other super concise and exam board specific A-level chemistry videos, click the button. Join me today and together let's make A-level chemistry a walk in the park.